Welcome to my presentation on real-time mobility analysis through Google Maps. This is submission number 70. My name is Ingmar Weber, and I'm from the Qatar Computing Research Institute. The work I will present is joint work with a number of people. So here you see the names of the whole team. So this is Tang, Soon-Gyo Jung, Rade Stanojevic, Noora Al-Emadi, G. Lucas, and myself. So what type of data are we looking at for this work? So here I'm showing a screenshot from my mobile phone where you can see that on my mobile device I've enabled the location history. So this is a Google feature. Okay, so Google, I allow Google to collect my location information. So why do I do this? Well, one of the benefits I get from this is that I can actually sort of see, where I was, at a day in the past, right? So here, this was before COVID, so February 12th, 2020. I was at home in the morning, and then I drove to work, spent the day at work, and then I drove back home, right? So this might be fun, sort of, right? But other benefits that I get from this include things such as personalized maps, recommendations based on places I visited, etc. Sort of, right? So this is why people such as myself opt in to share their location with Google. So what does Google do with this information? Actually, during COVID-19, they've started using this data and sharing aggregate insights through their Google Community Mobility reports. And you can see the URLs down here if you'd like to see those reports live. So here I'm showing part of a recent report for Qatar, where you can see that based on this mobility data, Google estimates that visits to locations under the category retail and recreation are currently down by about 13% compared to a baseline. I'll talk about that baseline in a second, right? And you can sort of see these sort of weekly patterns and that things seem to be gradually getting back to normal, right? And similarly, visits to grocery and pharmacy are even higher than an historic baseline. And the additional categories that I'm not showing down here. So concerning the baseline, this is all with respect to a 5-week period that dates from January 3rd to February 6th. So all of this is publicly available. This is not our data. I'm just sort of explaining the type of data that we're using for our work. So just a quick recap of the sort of mobility reports. So there's near global coverage for them. So almost all countries, except Iran, Cuba, North Korea, but then also some sort of small countries such as San Marino that would not be supported. Data is typically available within sort of 72 hours. There's one data point per day. Spatial resolution differs. So for small countries such as Qatar, you get data that's aggregated at the country level. But then for countries such as the US, it would be down to the sort of county level. So overall, this type of data is very, very valuable at the sort of strategic level to get like a broad insights into how people are still going out or not during the pandemic. But its value is somewhat more limited at the local and operational level because, for example, in the case of Qatar, it would be at the whole country level and only one data point per day. So just before talking about our data, still, if you're interested more in the Google Community Mobility reports, there's quite a bit of published work on this topic. So I would suggest that you have a look at Google Scholar for more work that uses this type of data. The work that I'll be talking about for the rest of the presentation is slightly different though. It comes from the same underlying source, but it has it's more fine-grained, right? And so here I'm showing a screenshot of Google Maps, where in particular I'm showing a petrol station in Bogota, Colombia. Okay, so you see the usual information, the address, etc., website, etc. But then down here on the left, you also see information about typical visit patterns in blue, as well as real time, at the moment when I took the screenshot, information about how many people are visiting the particular location. So this is sort of shown here in pink. So live at that moment, Google rated this as not too busy. So so there's sort of two elements to this, right? So there's a not too busy, which is sort of like the sort of absolute interpretation of the value in a sense. But then there's also the fact that if you compare to historically expected traffic at 1 a.m. on a Tuesday night, it's still much more than usual, right? So this is something maybe worth looking into, and we can sort of get to this later. This data is again, based on visits to this place, which is again sort of derived from people such as myself who have opted in to sharing their location with Google. So the reference in blue, which is sort of the typical expected patterns, are computed over the last few months. So we don't unfortunately know the precise period so that they're computed over. So this is already one of the limitations, and I'm going to get back to that at the end. And they are normalized. So they don't tell us exactly at this hour there were 20 people visiting or 200 or 2,000. We don't know. Everything is normalized with relative to the typical peak popularity. And again, you'll see that sort of later. So this is typical. It's similar to Google Trends if you've used that before. That also doesn't give you raw estimates of the number of times a search has been issued on Google, but everything is sort of normalized with respect to a peak of 100. Okay, so this is the type of data we use. So how do we actually collect it? Well, basically, we just issue regular requests to this maps/preview/place API endpoint. So here you see the URL pattern with a parameter for the given location. Right? And so then at this API endpoint, Google then returns a bit of JSON. And this JSON, so JSON's particular sort of data format, contains a lot of information, and this information includes details about the historic traffic and the live traffic. So this is what it looks like. I mean, JSON is just a text format, but here I'm using a sort of JSON viewer to have it slightly more readable. So the details, include what would you typically expect around 3 a.m. On the Monday morning. And here the crucial part is this value of 13. So this would be this value that you saw before, sort of in blue. So the historic reference would be something like a value of 13. This is out of 100. And then down here you have, at the current actual hour, which is also hour 3. So this is 3 a.m. In this case, it's on a Monday morning. But the current busyness in this particular example I'm showing here was a value of 9. So 9 is with respect to 100, but 9 could, the live busyness could potentially exceed 100. So if it's, if there's more traffic than historically seen during peak hours, you can occasionally get values that exceed a value of 100, but they're still normalized with respect to a value of 100. In this case, the peak hour is 11 a.m. on Tuesdays, where you have this value of 100 with a text description of usually as busy as it gets. In this particular case, the location in question is not the petrol station I showed before, but it's actually the airport in Bogota. Using this information and collecting it regularly for a number of locations, and not just in Bogota, but also in a number of other cities I will talk about later, we've put together a number of live dashboards. So here I'm showing a screenshot of the one for Bogota, and later I'll also show the URLs. So let me try to walk you through what you see here. On the top left, you can select the dates, the times, and the categories of interest. So for example, you can select, I'm interested in a particular date range or in a particular time of day, or I'm only interested in petrol stations, etc. Down here, just below, you have a little number that just is a summary of the total recent to total historic traffic as a sort of single summary of the overall mobility reduction or not as observed given the selection. Here you see details for the place that you've selected on the map, which is sort of down here. And here it's just a sort of total mobility summary, regardless of your selection criteria. So this shows across all categories and the whole date range how mobility patterns have changed. Here on the right, every dot corresponds to one location on Google Maps that provides this type of live information. Locations that are color-coded in red, like this one, this one, this one, and this one, have actually more traffic than historically expected, whereas locations in orange, yellow, and in particular green have less than historically expected. So green in particular would be no more than 40% of the historically expected volume for the given selection. And down here, you see that I selected a shopping mall called San Andresito, San Jose, Bogota, where you can further sort of see details about the comparison between historic and recent traffic. Just to go more concrete, so here I selected July 19th to Saturday, July 25th. Here the ratio of recent to historic is 0.81, so it basically corresponds to like a 19% reduction or 81% of historic traffic. Here you sort of see that the shopping mall that I selected in particular has a fairly large drop in visits. So again, in blue you have historic data, in sort of red or pink you have actually observed data. Down here you'll also see some discontinuities, and so once in a while, so this was I think around sort of June 26th, 25th, the number of locations that provided live information has changed. In this case it actually went up, and so then the total mobility that we managed to measure also goes up accordingly. So sometimes you have to be careful for when comparing certain things across these sort of discontinuities. And here is just for this particular location, for the given selection, this is 1 week, compared to a historic value of 3,079. Again, this is not visits, this is just some normalized value. Only 917 was observed. Okay, now what can you do with this sort of thing, right? And so again, it's all available live. You can do lots of things. You can see lots of pretty colors, but what's the sort of information you can derive from this? So one thing that you can see is that there is sort of spatial clustering, right? Like so for example, here's an area where it seems that in this neighborhood, it's not just one location, but all locations in this neighborhood seem to be at or close to their historic mobility patterns, right? And that's maybe good, right, in some sense, that they're close to normal, or it might be bad if you think that people should still be social distancing, right? And then similarly, there are other areas where all locations are well below their historic reference. Again, that could be good or bad, or sort of so, but might be worth knowing. And this sort of spatial granularity, you do not obtain through the Google Community Mobility reports. In terms of sort of spatial granularity, so here you can sort of, I'm showing something that looks at one particular hour, or rather 1 hour across a number of days. So it's always the 2 to 3 a.m. range from July 19th to 25th, first in Bogota, but only for petrol stations. So every dot here corresponds to a petrol station. And you see that almost all of them are colored in red, right? So this indicates that compared to normal periods between 2 and 3 a.m. in the morning, petrol stations are getting more traffic than usual, right? In this case, it's about twice as much traffic as historically expected. Why that is, I'll try to explain in a second. First, I'll show the same sort of phenomenon in Qatar. So in Qatar, we also compute values for regions. This is why you also have sort of more red coming in, because now these sort of points are taken to represent like a sort of wider geographic region. And again, this is only petrol stations between 2 and 3 in the morning. And here again, almost all petrol stations have more traffic than historically expected. In Qatar, it's even more pronounced, a factor of almost 6, right? And both, I mean, in Qatar in particular, where we are more familiar with the situation, and probably also in Bogota, where at least personally I'm not as familiar with the situation, we would hypothesize that people are shifting their shopping habits, because at least in Qatar, many of the petrol stations have sort of small mini marts attached to them, right? Like sort of. So these are the sort of insights that you can get through these platforms. You see, so people are. In this case, it's actually good that there's more than usual traffic, right? Because at night, of course, in absolute terms, the traffic is still very low, and probably it indicates that people, changing their shopping behavior in ways that are probably beneficial in terms of social distancing. Here, I'm just listing some of the sort of deployments and sort of related findings. So in Qatar, this dashboard is used operationally by the Ministry of Public Health. I mean, for example, to monitor a stay-at-home recommendation. Some of the insights that we observed, already mentioned the one related to petrol stations. There are also similar ones to shifts in when supermarkets are being sort of visited, where there seems to be like a flattening of the peaks, sort of also in particular the evening peak, which is usually sort of the rush hour, seems to be somewhat reduced, whereas the morning peak which is not quite as pronounced, still seems to be there, right? So people seem to be naturally spreading out in terms of sort of time. The dashboard that we created for Lagos in Nigeria is part of the Nigeria's national coronavirus geospatial data hub, which we are quite proud of. And there's also an NGO that uses our dashboard for Nairobi to assess curfew compliance. So these are some of the use cases that we're aware of, but others have approached us, asking whether this could also be used, for example, to monitor economic recovery, sort of. So this is something that might be possible, but that we have not done ourselves yet. Some of the limitations around this data. So there are different types of selection bias. So first, not all locations provide live information. So most importantly, only very, very popular locations provide live information. So this is due to anonymity limitations, right? So if there's a location where there's only one person visiting a day, then obviously this would be sort of problematic to report this data, even if it's supposedly anonymous and aggregate, because you could probably identify individuals. So main bias is towards very popular locations. Another bias is that certain categories are excluded. So in particular, hospitals, where having visit information might again be sort of too sensitive. And so for those, Google does not report visit information. Then there's another bias on the users who opt in to share their location, right? So they have to be, of course, somewhat weird, maybe, I don't know, such as myself. On the other hand, Google makes it very, very easy when you set up your Android phone to opt in. You almost have to sort of, opt out in a sense, even though it's strictly speaking an opt-in a mechanism, right? Still, but overall, there will be a skew probably towards Android users, which might be skewed in some way in terms of demographics. Maybe typically iOS devices are more expensive, so maybe now you're only picking up devices with maybe cheaper, people with, let's say, maybe cheaper devices, or not. It's sort of hard to say. We don't really know. The number of black box issues when you sort of use this type of company data. So one relates to the historic baselines. So we don't exactly know what the historic baseline is and if it's the same as for the other report or not. We don't think it's the same because at least we've occasionally observed some updates, although most of the updates affect rather the selection of places, not necessarily their historic baseline. Still, it's somehow hard to know what exactly the historic baseline is, sort of. So it's just the past few months, but what period exactly, we don't know. Another issue is everything is normalized, that I already mentioned. So it's impossible to know which location sees the highest number of visits because, again, everything is normalized within a particular location, which might or might not matter depending on the application you have in mind. And then finally, there's no historic data, right? So if you were interested in having this sort of analysis done for a month ago or 3 months or 4 months ago, unless it is for a city where we've already been collecting data over that period of time, we would not be able, or nobody would be able to sort of provide this sort of analysis for you, right? And so as such, you have to sort of start collecting data now so that in the future you have some historic data to look at. Here I'm showing a few of the public dashboards that we've made available. There are more, but most of the other ones have a fairly small number of locations, so they might not be as interesting. Another thing that you will observe here in the list is that there's, again, a certain bias sort of aside. So for example, here there's a city called Rostock, in Germany that has 140 locations, and you might have never heard of the city before, but you've almost surely heard of Accra, Casablanca, or Lagos before, which are cities that are all far, far, far bigger than Rostock, right? Sort of so. But still, in these cities, we did not find the same number of locations with live information, sort of so. So supposedly because either mobile phones or Android phones or people who opt in to share the locations are not as widespread as in this German city of Rostock. If you'd like another city to be included in this list, in particular, if you have a particular use case in mind, please get in touch, and we'd be happy to, sort of start collecting data. If you have additional questions or comments or sort of also, we'd love to hear from you. So please get in touch. Here's my email address. Yeah, I look forward to hearing from you. So thank you so much for listening to our presentation.